Explore more about the topics you love with Toppr. Subscribe now and keep learning.
Hi, in this class we will continue our study of set theory and we will now see some laws that sets obey or follow, or the laws that are applicable to sets. So, the first law that we are going to see that applies to set is the idempotent laws. So, let us see what are these idempotent laws that apply to sets. Suppose we have a set A, then the union of a set with itself will be the set A itself. So, the idempotent law says that union of any set with itself will result in the same set. Again, we also have another statement of this law, which is the intersection of any set with itself again results in the same set. So, if we are taking a general set A, then the intersection of that set with itself will give the set A back. And let us now come to commutative laws. Now, commutative laws that apply to sets mean that whenever we have two sets A and B, then the intersection of those two sets A and B can be taken in any order. So, if we perform A intersection B, then that is equivalent to performing B intersection A. That is, the order in which the sets are subjected to the intersection operation does not matter. Now, let us see another statement which is again under the same category of commutative laws, and this law applies to union. And so now we are looking at two sets A and B again, which are any general sets, and this law states that if we perform the union of sets A and B, then that is equivalent to performing the union of sets B and A. So it means that the operation in which intersection and union are applied on sets is not very important. So we can always apply A intersection B and we can equivalently apply B intersection A to give us the same result. Likewise, even for union, we can do A union B or B union A to give us the same result. So let us now come to the third set of laws known as associative laws. So let us see what are these associative laws. Now, these associative laws apply to three sets. So earlier in the idempotent law, we had looked at a single set, and in case of commutative laws, we took the example of two sets A and B. And now to understand associative laws, we will take three sets A, B and C. And the associative law states that whenever we perform the intersection of sets A, B and C, then that intersection can be performed in any order. What it means is, if I perform A intersection B first, and then in the resulting set, I then perform intersection of that resulting set with another set C, then that is equivalent to performing the intersection of sets A and the set formed by the intersection of sets B and C. So if you notice in this law, here we are performing A intersection B first, and in the resulting set, we are performing the intersection of that resulting set again with the set C. And that is equivalent to first performing intersection of sets B and C and then subjecting that resulting set to the intersection with set A. Similar is the case with union in case of associative laws. So if we are now performing the union of three sets A union B union C, then what this law states is, if we first perform the union of A and B and apply the union of C to that resulting set, then the result is exactly the same what we get after first performing union of B and C. So I am first performing B union C here and then subjecting that set to union with the set A. So now we have seen what are the associative laws that are applicable to three sets. Next we look at the identity laws, and these laws state whenever we have a general set A, then if we perform intersection of that set with the null set denoted by this symbol phi, then the result that we get is equal to the null set. So what this law states that if we have a null set and if we perform intersection of any given set with the null set, then the result is again the null set. Well, let us now study the union of a general set A and the null set. So now if we have a set A and we perform union of that set A with the null set denoted by phi, then we can say that the union of any set with the null set gives us the same set back. That is, a set A whose union is taken with the null set or the empty set gives us the set A back. Let us now look at two more statements of these identity laws. This time we will take the universal set, and so we will first perform intersection of sets A and the universal set, and so we can now write A intersection U, where U represents the universal set. And now this law states that whenever we perform the intersection of sets A and the universal set, the result that we get is the set A back. Now let us come to the fourth and final case where we are considering the union of sets A and the universal set. So now we are taking this set A and performing union with the universal set, and whenever the union of any set A is taken with the universal set, then the result is the universal set. So whenever we have a universal set and it is subjected to union with any set A, then the result again is the universal set. Next we will consider what are the distributive laws. So to understand distributive laws, we will again consider the example of any three general sets A, B and C. And the statements of the distributive laws are, if we have an operation A union B intersection C. So now we are talking about A union B intersection C, where we are performing B intersection C first and subjecting that resulting set to union with set A. Then the value of this set or this operation results in a set that is equal to the set obtained by performing A union B intersection A union C. So now this law states that this set A can be combined with this set B by a union operation, and then of that resulting set we take intersection of that set with another set formed by combining A with set C. So it says that this union operation is distributive over intersection, and so this is the first statement of the distributive law. Let us look at the other statement. Well, the other statement you should now be able to guess is that we will replace this union by an intersection and this inner intersection by a union, and so we will take same sets A, B and C, and we can now write A intersection B union C. So now we are doing intersection of B union C with the set A, and the result obtained is equivalent to the set A intersection B union A intersection C. So now this result tells us that whenever we have three sets A, B and C, then if we perform the union of sets B and C first and subject that resulting set to intersection with set A, then the result obtained is the same as that obtained by the union of sets A intersection B and A intersection C. Let us look at the next set of laws that come under the category of De Morgan's laws. And these laws state that whenever we have two sets A and B, and suppose we perform the intersection of sets A and B, then if we obtain the intersection of sets A and B and then perform its complement, where the superscript C denotes the complement now, then the result obtained or the set obtained is exactly equal to the set that we obtain after performing complement of set A, then performing the complement of set B, and then subjecting these two sets, resulting sets, to the union operation. So now this law states that when we are performing complement of an intersection of two sets, then the result is the same as doing the union of their respective complements. And so A intersection B, whose complement is taken, is now equivalent to union of A complement and B complement. So let us now look at the next statement of the De Morgan's laws. Again we will replace every intersection with a union and every union with an intersection, and so the law should be easy to guess now. Again we are talking about two sets A and B, but this time we are talking about union of two sets A and B. And suppose we perform union of sets A and B and take the complement of the resulting set, then the result obtained is exactly the same as that we obtain after performing complements of the sets A and B and then taking their intersection. So now if you notice these laws, you will realize that in De Morgan's laws, whenever we have a complement of an intersection, then we get union of its respective complements, and likewise when we perform complement of union, then we get intersection of the respective complements. Well, there are two more statements in relation with De Morgan's laws which apply to the difference operator. Let us now look at the next statement of the De Morgan's laws, and the statement says when we have three sets A, B and C, so I will write down the three sets A, B and C first. And now this statement of the De Morgan's laws states that whenever we perform intersection of sets B and C and then the resulting set is subtracted from the set A, or in other words when we are performing the difference of sets A and sets B intersection C, then the result obtained is same as the union of sets A minus B and A minus C. So now this law states that whenever we have three sets A, B and C, then if we perform the difference of sets A and B intersection C, then the result obtained is same as performing the union of sets A minus B and A minus C. So now this intersection that was here has turned into a union. So in every De Morgan's law, if you have an intersection on the left hand side, you get a union on the right hand side. Let us now look at the fourth statement of the De Morgan's laws. And this statement says that if we have three sets A, B and C, so again we are dealing with three sets A, B and C which are general sets, and now if we perform the difference of sets A and set B union C, then the result obtained is same as performing the intersection of sets A minus B and A minus C. So now we have stated these laws that are applicable to sets in general. So now to take a brief recap of what we've already learned, the idempotent laws that apply to sets deal with a single set A, and it says that the union or intersection of a set with itself gives the same set back. Next we saw the commutative laws which say that the operations union and intersection are commutative, that is A intersection B is same as B intersection A, and similar is the case with union. The next set of laws we saw were the associative laws in which we dealt with three or more sets. Now we stated the laws for three sets, but this can be applied and extended to more than three sets. So this law states that intersection and union operations are all associative, that is the order in which they are performed is immaterial, they give us the same result. Next we had seen the identity laws in which we saw the combination of set A with the null set phi and also with the universal set U, and we observed that upon intersection of a set A with a null set, the result is again a null set, whereas the union of a set A with a null set gives us the set A back. In a similar manner, we saw that a set A whose intersection is taken with the universal set results in the set A back, and again a set A whose union is taken with the universal set results in the universal set back. The next set of laws that we saw were the distributive laws, and they said that whenever we had three sets, then the operations of union and intersection were distributive over the sets. So if we have A union B intersection C, then the result is same as performing A union B intersection A union C. So this union operation is distributive over this intersection operation inside the bracket. In a similar manner, we also saw that A intersection B union C is same as A intersection B union A intersection C, which means this intersection operation is again distributive over union. Well, the next set of laws that we saw were the De Morgan's laws, and the first statement of the De Morgan's law said that if we have two sets A and B, then the intersection of the two sets when performed and the complement of the intersection was taken, then the result will be equal to taking the union of their respective complements. So whenever this intersection sign is taken out of the complement bracket, we get a union of the respective complements. In a similar manner, when we perform the union of sets A and B and then we perform the complement of that union, then the result that we get is equivalent to the intersection of their respective complements. Next we saw another statement of the De Morgan's laws, this time applying to three sets A, B and C, and the first statement was the difference of sets A and the set B intersection C was equivalent to the union of sets A difference B and A minus C, that is A minus B and A minus C. Now the final statement of the De Morgan's laws was whenever we had three sets A, B and C, then the difference of sets A and the set B union C was equivalent to the intersection of sets A minus B and A minus C. Well, we will understand these laws with examples and also with the help of diagrams in Venn diagrams. So now having seen these laws that apply to sets, we can use any law that is stated over here in order to solve problems related to set theory. So now to understand these laws better, we will introduce a concept known as Venn diagram in the next class.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.